Is Gurkirt Singh. I'm going to present our joint work with my colleague from CVL at ETH Zurich titled Spatial-Temporal Action Detection Under Large Motion. Spatial-temporal action detection can be defined as a problem of finding spatial and temporal bounds of action instances where spatial bounds are defined by bounding boxes and temporal bounds are defined by linking these frame level boxes from point where action starts to a point where action ends. Keyframe based methods are common in recent work to solve this problem because these are simple and efficient. Here, a set of bounding box proposals are generated for a keyframe in a parallel. Spatial temporal features are computed using a 3D backbone network. Proposals are then used to extract feature by replicating proposals in time direction, resulting in a feature accumulated of each proposal in a cuboid shape. However, such a cuboid would fail to accumulate meaningful feature when there is a large motion present, because spatial location of an actor changes drastically over time, which cuboid would fail to cover. Large motion in actor's spatial position can occur due to a large camera motion or due to a fast action. Example, pike jump action on the right occur in a less than 1 second of time. We define an actor motion with intersection over union time between the boxes of a tube at a fixed time scale. The action having a large motion would present in a lower intersection over union over time, and slower action would maintain a higher intersection over union. Using such a definition, we can measure motion present in various action detection datasets. Here we show cumulative density function of intersection over union measurements on a training sets of AVA, UCF24 and MultiSports dataset. Plots indicate that MultiSport datasets a large number of instances with a large motion, hence ideal for this study. We ask ourselves if early tracking would help. We hypothesize that it would help to accumulate accurate feature, but it could also generate unstable feature if tracking is not so good. As a result, we proposed a track-aware action detector. Given input clip with frames, we extract features using video network and in parallel per actor tracks from an offline tracker. Track of interest align operation extract per track features to an array. Next, temporal feature aggregation module aggregate the features along the temporal dimension and passes to a classifier for action labeling. We tried various temporal feature aggregation modules. Some of them worked, some of them did not result in stable training. Here we show frame level results on MultiSports datasets split based on motion categories, and we compare our method with a baseline. Our method outperformed cuboid based baseline by large margin, especially in cases large motion instances. Gains in large motion instances are almost twice that of gains made on small motion instances. We see similar trends on video level action tube detection and UCF24 dataset. Our method outperformed baseline by large margin across the board. Finally, our method outperformed all other state-of-the-art approaches on MultiSports, including last year's challenge winner. We submitted our result on test server and we won this year's challenge comfortably in October 22. We also observed similar trends when it comes to qualitative results. I would like to conclude that our proposed track-aware feature aggregation accumulation helps in action detection, especially for instances with large motion.